Now let's take the very first question. Here it says that the number of 3-digit even numbers which should be formed using this digit if the repetition of digit is not allowed. So it's a very simple question. We can just take the cases and find the number of numbers possible. So if there is a 3-digit number, let us fix 0 at this place. Thereby we have these two places for which we have these 5 options. So here I can have 5 options, here I can have 4 options. So overall the number of numbers ending with 0 will be 20. Similarly, if I fix 4, then for these two places I have 0, 1, 3, 6 and 7, but 0 can't appear at this place, so we'll have only these 4 options, correct? For this again we can't use the number here which we have used here, but we can use 0, so again the number of options will be 4, so it comes out to be 16. The same thing will happen if I fix the number 6. It will be 4 into 4, which comes out to be 16. So we have to add all these three numbers, which comes out to be 52, and that is the answer. Let's take the next question. Here it says that the sum of all the 3-digit number less than or equal to 500 which are formed without using the digit 1 and they are multiple of 11. So for solving this question, what we can do is that we can write all the numbers which are multiple of 11, 3-digit number, wherein 1 is not appearing at the 100 place, because anyway we have to ignore those numbers which are not having a digit 1. So the smallest number will be 209, right? Because this is the number which is divisible by 11. We have the method of finding the divisibility by 11, that if there are 3-digit number, then the sum of these two, and if I deduct b from here, then that difference should be either 0 or any number which is multiple of 11. Since these are digits, definitely I'm taking that the number is difference is 0, right? Difference is either 0 or 11. The next number definitely would be, if I add 11 here, it will be 220. Then next number would be 231, so on and so forth. Although I'm taking a number which has a digit 1 at the tens place or at the ones place, we will be deducting those numbers later on. The last number would be 495. So these are the numbers. So let us find that how many terms it has. So 495 is the last term. This is the first term. So first term plus n minus 1 into common difference would be 11, because we are taking all the numbers which are multiple of 11, right? So n minus 1 would be 495 minus 209, which would be, it would be 6 here, and this is 8 and this is 2, right? So this is multiplied by 11, right? So the value of n minus 1 would be 286 divided by 11, which is 26, or the value of n would be 27. So there are 27 such numbers. So we can find the sum of all these numbers by using some series sum formula, that is it will be n divided by 2, first term plus the last term, correct? This on calculation will be getting it as 9504. Now we are also adding those numbers which has digit 1 either in the unit place or at the tens place. So let us just figure out those numbers. So if the number ends with 1, then these two numbers, the sum of these two taken minus this should be equal to 0, so that the number becomes divisible by 11. So what we can take is that if the unit digit is 1, then let us take 2 and 3, so that sum of these two is equal to the middle number. Similarly, if I take this as 1, this as 3, then this will be 4. Take this one, then this as 4, and this will be 5. Further, I will not be taking number because I have to take the number which are less than or equal to 500. So these are the numbers which ends with 1. Now let us assume, let us take those number where in the middle number is 1. If this is 1, then we can take, say, if I take this to be 3, then this will be 9. If this is 1, if I take 8, then this will be 4. These are the only two numbers possible. So sum of all these 5 numbers need to be deducted from here. If I add these 5 numbers, then it comes out to be 1760. So we have to deduct it from 9505 1760, which comes out to be 7744. So this becomes our answer. Let's take the third question. Here it said that the number of 6 letter word with or without meaning formed by using all the letters of the word vowels, so that the consonant never come together. Again, a very easy question. Here we can see that apart from O and E, rest 4 letters are consonants. So if I take consonant and bundle them up like this, we'll assume it to be one letter and the other two letters are O and E. Then the number of ways these three things can be arranged is 3 factorial ways, right? Further, these letter among the bundle can be arranged in 4 factorial ways, which is equal to 144. So these are the arrangements wherein all the consonants are together, but we need to find all consonants should never come together. So what we can do is that we can take the total ways of arranging them without any condition. That will be 6 factorial directly, because there are 6 letters. So we have to deduct those cases which is having all the consonant at one place. So minus 144 we have to find out. So it will be 6 factorial is 720 minus 144, which comes out to be 576, which is the answer. Next is question number 4. A scientific committee is to be formed from 6 Indians and 8 foreigners, which include at least 2 Indians and double the number of foreigners as Indians. Then the number of ways the committee can be formed. So we can start with making cases that number of Indians and number of foreigners. If it is 2, then the number of foreigners has to be double than the Indians, right? So it should be 4. This case can be done. The 2 Indians can be selected out of 6 in 6 C2 ways, and 4 foreigners out of 8 would be 8 C4 ways. Next is, if the number of Indians is 3, then this would be 6, correct? So which can be done in 6C3 ways into 8C6 ways. And if I take it 4, then this would be 8. So it would be 6C4 into 8C8, right? So we have to calculate this. So this would be equal to, this is equal to 1050, this will be equal to 560, and this is 15. So we have to add all these numbers. On addition, I'll be getting it as 1625, and that is the answer. Now let's take the fifth question. Here it says that the total number of positive integral solution x, y, and z such that the product of all three is 24. You know that x into y into z, if I factorize it, it will be 2 to the power 3 into 3 to the power 1. Each of these factors will contain 2's and 3's, right? Some number of 2's and some number of 3's. Definitely 2's will never increase by 3 and 3 will never increase by 1. And taking the product, the total number of 2's will always be 3 and total number of 3's will always be 1. So assuming that x is in the form of 2 to the power alpha into 3 to the power beta 1, right? Similarly, y can be assumed at 2 to the power alpha 2 into 3 to the power beta 2, and z is 2 to the power alpha 3 into 3 to the power beta 3. Clearly, if I take the product, then we can say that sum of alpha 1, alpha 2, alpha 3 has to be 3, right? Alpha 1 plus alpha 2 plus alpha 3 has to be equal to 3, and sum of beta 1 plus beta 2 plus beta 3 has to be equal to 1. Now number of integral solution, non-negative integral solution for this would be what? This is the value of n, number of r, the value of r is also 3. So it will be 3 plus 3 minus 1 c, 3 minus 1, which comes out to be 5 c2. So number of ways solution is, number of integral solution is 5 c2 here. For this, the value of n is 1, the value of r is 3, so it is 1 plus 3 minus 1 c, 3 minus 1, which comes out to be 3 c2. So it would be 3c2, right? This is equal to 10, this is equal to 3. Together they can be done in 10 into 3, which is equal to 30 ways. So 30 is the total number of ordered pair solution for x, y, and z in this case. Let us take the sixth question. So here it says that the number of 7-digit integer with the sum of the digit equal to 10 and formed by using the digit 1, 2, and 3 only. So if I take only ones 7 times, then the sum is not equal to 10, right? So we have to ignore some of the ones and replace it by 2 or 3. So if I replace 1 by 2, then the sum becomes 8, which again is not sufficient. So I should replace 2 ones. So here it should be 2, 2. So the sum becomes 5 plus 4, which is 9. So what we can do is that we can tweak it, replace this 2 with 3. This is one way wherein the sum is 10, right? The number of arrangements would be what? 7 factorial divided by 1 is appearing 5 times, so divided by 5 factorial, which comes out to be 7 into 6 or 42. Next is we can take we can replace this 3 by 2 and adding 1 here, so it will be 1 1 1 1 2 2 2. right? This is another way of getting the sum as 10. This can be done as 7 factorial divided by 4 factorial into 3 factorial, which comes out to be 7 into 6 into 5 divided by 6, which is 35. There is no other way wherein we can get 7 digit whose sum is 10. Reason being, if I ignore any of the 1 or 2s and try to replace it with 3, the sum will get distorted. It will be either more than 10 or it will be less than 10. So these are the only two values. So we have to add them. The answer comes out to be 77. Let's take the seventh question. Here it says that the letter entrance is arranged in all possible ways. Number of arrangement we have to find where E's and N's are together. So there are two E's and two N's. So what we can do is that we can make a bundle out of it. And the other letters are T, R, A, and C. So overall, if I consider this as one unit, then the total number of letters would be 5. They can be arranged in 5 factorial ways. Within this, these numbers can be arranged in 4 factorial divided by 2 factorial into 2 factorial ways. So calculating this will be 120 multiplied by 4 factorial divided by 4 is 6. So the overall the answer would be 6 factorial or 720. Now question number 8, it says that a picnic party of 4 persons is to be selected from 8 male and 3 females so as to include at least 1 female. It's a very easy question. What we can do is that the total number of possibilities is that out of 11 we have to select 4 people. We have to deduct those possibilities wherein no female is selected. That means all 4 people will be selected from these 8 male, so it would be 8C4. So we have to calculate this on calculus and we'll be getting it as 260, and that becomes the right answer. Now question number 9, it says that a necklace is a circular string with several beads on it. It is allowed to rotate a necklace but do not turn it over. Then how many different necklaces can be made with 13 beads? It's a similar case of arranging, say, 13 people on a circular table, right? Because we can't turn the table. That's what the question is saying. So if there are n number of people, then the number of ways of arranging them in a circle is what? N minus 1 factorial. So clearly the value of n is 13. The answer would be 12 factorial. The last question here, it says that the number of ways of distributing 10 different books among 4 students. These are the students such that S1 and S2 they get 2 books and S3 and S4 they get 3 books each. It's a simple case. For the first student we have to give him 2 books, right? So out of 10 we can select any 2, so it is 10C2 ways. From the balance 8 again we can select 2 books which will be given to S2. From the balance we'll be selecting 3 which will be given to S3, and from the balance 3 we'll be selecting all 3 which will be given to S4. This on simplification will be getting option number 4.